Hey there, welcome back to STM32 coding for everyone. In this tutorial, we're going to build a simple USART driver and display data on a virtual terminal. So by the end of this tutorial, you should be able to show your collected data on a Tera Term virtual terminal or on a PuTTY terminal. Whatever virtual terminal you are more comfortable with, we're going to get data from our Nucleo board here and transmit it over the serial port using the USART driver. Now, without any further ado, I'm going to go ahead and make a copy of this previous tutorial, and we're going to build our USART driver from the settings on this tutorial, because I already have the LCD driver on this tutorial. Because I still want to display, please subscribe and like this tutorial if you find it useful. So I'm going to go ahead and paste, and I'm just going to rename these. Great, now I've got my copy of the USART driver project. I'm going to go ahead and click on the USART driver.ioc so that we can start configuring our Nucleo board. Okay, now the project have been created with the previous version, so I'm just going to go ahead and migrate. Great, now once your iOS interface is loaded, the first thing you need to check is to ensure that you are running with the appropriate system clock. You need to pay attention to your peripheral bus clock frequency to ensure that you have the correct frequency for your bus where your USART is connected. So what we're going to do, the next thing here is to click on connectivity. As you can see here, the previous project was on the SPI, so we basically just going to disable this now. Great, now let's go ahead and select one of the USART hardware that we've got here. So please ensure that the particular USART for your Nucleo board actually support the virtual terminal. So if your Nucleo board USART virtual terminal is on USART 2 or USART 1, please make sure you use that particular one. The Nucleo board version I'm using have the virtual terminal on USART 2. So if you are not sure, you can look it up in your reference manual, or keep on trying all three of them until you can get the one that will work for you. Now, the next thing we're going to do is to basically enable our USART in asynchronous mode, right? That's basically what the A stand here in the USART, while the S stand for synchronous. But right now we're only going to use it in asynchronous mode. So basically the S got no use to us. Okay, so it's basically going to be UART, Universal Asynchronous Receiver-Transmitter. Great, now the next thing we need to do is to complete a setting for our USART driver. So I'm going to pull up the configuration here. The first thing is the baud rate. So I'm going to give it a baud rate of 19200, right? So that will be our baud rate. The word length will be 8 bits, parity none, stop bit 1, basically just the default settings. So the direction here is receive and transmit. Okay, so that is the full duplex there. If you want to run it on half duplex, basically just single wire half duplex that way. And if you select that, then over here you can choose receive only or transmit only. Over sampling settings, we're going to leave it as 16 sample, as that is already the correct setting for our hardware. Okay, so now what else we need to do here? That basically all we need to do. My configuration for my LCD will remain as is. Great, so that's basically all we need here for our USART driver. But now before we generate the code, let's go ahead and add support for the analog to digital conversion, because as you can see, I've got an LDR here. So I'm going to get data from the LDR as I measure my light here and display it on the virtual terminal. So to be able to do that, I need to enable my ADC. So I'm going to go ahead and click on ADC 1 here. And over here, I'm going to choose a second one and enable the single-ended conversion. So that will basically give me the conversions at PA1. Great. Now, the next thing here is to just make things simple here. We're going to do a simple continuous conversion mode here. Okay, so everything is left as is here. All we need to do is to enable the conversion here, basically the number of conversion. Okay, so we're just going to do 1 conversion. Okay, once you set up your number of conversion, then you can go back up in your settings here and enable the continuous conversion mode. Okay, so that's basically all you need to do here, nothing else. Okay, so you leave your clock prescaler to ADC asynchronous clock mode, resolution 12-bit, continuous conversion enable, and the number of conversion set to 1. Now we can go ahead and generate the code here. Okay, now if you want to know more about ADC conversion, please, I've got a couple of series of tutorial where we do ADC in direct memory access, interrupt mode, polling mode, and continuous conversion mode. Great, our code completion is completed. The first thing we need to do is to basically create our private variable definition. So I'm going to go ahead and create a character array that will basically hold the message that I want to transmit over the virtual terminal. So let's go ahead and paste these few lines of code. So we're creating a character array of size 30, and we've got a timeout, and we've got an integer variable LDR underscore row that will basically hold the values, the raw data coming from our light dependent resistor. Then, as always, we trust that the code that was generated for us is very good. We don't have to scrutinize it, but if you want to ensure that everything is as is, you can go ahead and double check on all the settings that we've done. Okay, so you got 12-bit resolution basically for your ADC, and over here you got the initialization for your USART 2. Okay, so now let's go ahead into the while loop where the magic is going to happen. Now, the first thing we're going to do inside the user code begin, as you can see, we still got our data here for the LCD being handled for us. So let's go ahead and start the ADC, right? That's the first thing we need to do. So we're going to start ADC, and we're going to get the ADC value. Now remember, this is just happening in continuous conversion mode. So we start the ADC, and we call the ADC polling for conversions, and we pass a timeout variable of 1. Okay, and we then take our LDR row variable, then we pass the data we're going to collect from the ADC, and the raw data will basically be coming from our LDR here, which is connected on PA1 as we have specified in our configuration. Okay, now the next thing we need to do here is to basically get the printf function that we're going to pass the message and the data that we're going to collect. Okay, so that's very simple for us. So we call the printf function, and the parameters for the printf function here will basically going to be passing the string LDR raw data, and the LDR raw data itself that we're basically collecting and formatted as integer here. We're taking all of that and passing it into this character MSG. Great. Now the next thing we need to do is to basically call the transmission function that will then take these message here that we basically just coded with the string and the raw data, and we're going to pass it to the transmission function and take it to the next step, basically to pass it to the virtual terminal. Okay, so that will be our USART driver. Now in this transmission message here, we basically just have the message pointer and the size of the message here, which is 30, that we already defined in that character array, and the maximum delay to ensure that we don't lose any data during the transmission. So that's basically all we need to do here. Great. Now let's go ahead and build this project, compile it, and hopefully we won't be getting any errors or warning during our compilation here. We basically changed a few lines of code, and we inherited some of the code from the previous tutorial. Okay, now so far so good. It seems like, oops, we've got some problem here. Warning, implicit declaration. There is an SPI function here. There we go. Okay, so this one must be removed. Okay, so we don't need it because this is from the SPI driver. I hope that's the only problem we've got here. Okay, So let's go ahead and build this one more time. Great. So this time around there are no problem. Okay, so the code compilation was a success. Now I'm going to go ahead and load this into our Nucleo board. So please make sure you select the USART driver. Don't load any other driver in. We are interested in the USART driver because we want to see data flowing from the virtual terminal. Okay, so okay, I'm going to bring my Tera Term terminal here. Okay, and as we wait for the debugger to start loading the data. Great, the debugger is done with loading our code, but we're not getting anything here. Obviously we need to change our COM port here. Okay, we need COM port 8, right? That is where our STM microelectronics is located, our virtual port, and we need to change the baud rate to 19200. That is what we set on our settings. So close and new open, right? Okay, whoops, cannot open COM8. Okay, I think I still got COM8 on the PuTTY terminal here. Okay, there we go. PuTTY is busy here, so I'm going to close PuTTY. Okay, and we're going to basically just reset this. Okay, so new open, there we go. We are getting data here, but we need to reset the terminal here. Let's go ahead and reset the terminal. Great, there we go. The terminal is now clean and we can read everything. And as soon as I put some shade on my LDR, you can see the count is getting lower and lower. That basically the LDR for you, a very sensitive light dependent resistor. Great, so that's basically how you can get data transferred using the USART serial interface. Now I'm going to close this and let's check PuTTY again. Where is PuTTY, so that we can see how we can get PuTTY configured in the setup. So let's go ahead and select serial. Okay, and we're going to change the baud rate 19200 and we can open the COM port. As you can see, the data are still coming through with our PuTTY terminal here. And as always, we can bring the countdown of our raw value from the LDR. Great, so that is basically it for this tutorial, guys. So I'm going to stop this tutorial here, right? So in the next tutorial, basically we're going to make part 2 of this tutorial, where I'm going to show you how you can basically get this information here and log it using your Python script and log it onto a CSV file. So that will basically be a very quick tutorial, and that will be coming up in the next tutorial. So if you find this tutorial useful, please make sure you subscribe to CMTEQ channel and give this tutorial a thumbs up. Until next time, cheers.